All right, welcome back to your favorite pre-cal course. We're going to take a look at one-to-one functions and then inverse functions. So first of all, what is a one-to-one function? A function is one-to-one. So first of all, it has to be a function. A function, so it has to be a function, meaning it has to first pass the vertical line test. For every input, there's one output. A function f is one-to-one if, and this is your classic definition, if a is not equal to b, then f of a cannot be equal to f of b. In other words, for every y value, there can be only one x value. So we're going to test this using the horizontal line test. Right? Because the horizontal line test will test, like let's say we have a quadratic, for example. If a is not equal to b, then when I run a line, it'll show me if f of a is not equal to f of b. Well, it fails here, right? In other words, for every y, there's two different x's. So this is not, a quadratic function is not one-to-one. Right? Let's do these ones down here. Let's test these using the horizontal line test. You notice we run the horizontal line test, it fails. It hits 3 times. It can only hit once. So this is not one-to-one. And we should also check if it's a function first of all. So is b a function? Yes, it is. Passes the vertical line test. Now does it pass the horizontal? Yes, it only hits once. Only hits once. Anywhere we draw a horizontal line test, that function hits only once. So this, yes, is a one-to-one function. C is not, because it fails the vertical line test. So it's not even a function. So we can't, since it's not even a function, we can't even test it to be one-to-one. We can't even run the horizontal line test, right? So why do we even care about one-to-one functions? Well, to have an inverse, it must be function. To have an inverse, inverse, oh my goodness, I can't spell. To have an inverse, oh my gosh, inverse, then the function, so it has to be a function, must be one-to-one, right? In order to have an inverse, it's got to be one-to-one, right? So if you have like a set of, let's talk about inverses for a minute. Let's say we have a set of points. I don't know. Let's say we got 1, 1, 2, 4, 3, 9. And I'm going to throw in 0, 0. 0, 0, 1, 1, 2, 4, 3, 9. Okay, here's this function from there to there. I'm going to connect the dots, so there's more points than that, okay? Its inverse, I'm going to do in red. The inverse would flip-flop all those x's and y's. So instead of 0, 0, flips around 0, 0. Instead of 1, 1, flips around, it's still 1, 1. So 0, 0, 1, 1 are the same. But 2, 4 becomes 4, 2. 3, 9 becomes 9, 3. So we got 4, 2, 9, 3, and so on. And draw this very good. And here's the one in red. Okay, so here's our original f function, and we would use the notation f inverse for the red function. Again, all the points flip-flop to be an inverse, and you may recall their reflection about the line y equals x, right? Their reflection about that black line, right? Their flip-flop around that, because all the x and y points flip-flop, right? Well, inverse functions also have this property right here. F of g of x will spit out x, and g of f of x will spit out x. So if they're truly inverses, in other words, if g and f are inverses, then that will be true, okay? So points flip-flop. Let's look at this first one. So if f of 10 equals 14, if f of 10 equals 14, right? So in other words, we have the point 10, 3, 4, 5, 6, 7, 8, 9, 10, 14. Is that 14? Anyways, 10, 14. Then f inverse of 14 would spit out 10. It just flips it around. So instead of the point 10, 14, it'd be 14, 10, right? All right, so how would we verify inverses? Well, the only way to verify, if f and g are inverses, in other words, g is f inverse, if they're truly inverses, then we have to test to verify. This has to be true. F of g of x has to spit out x, and g of f of x has to spit out x. If it satisfies both of those, they are inverses. So let's start with the first one. F of g of x. So let's find g of x, and we're trying to see g of x is 1/2 x plus 1/2. And we're just trying to make sure it's equal to x. Right? So I'm just going to work with this left-hand side and see if it gives me x equaling x. Okay. So I'm working with f now. F is 2x minus 1. And what goes in? G goes in. 1/2 x plus 1/2. Let's go ahead and distribute that. So we got 1x plus 1. We've got the minus 1. Those, of course, cancel. X equals x. Okay, so far so good. F of g of x equals x. That's true. Now let's go g of f of x. So g of f of x. F of x is 2x minus 1. And we got to see if this is equal to x. So we're using g, which is 1/2 x plus 1/2. Again, we're just working with the left-hand side here, g of x, or g of f of x, or sorry, f of x is 2x minus 1, so that goes into g. And let's go ahead and distribute. So we got 2x over 2, so x minus 1/2 plus the 1/2 still equals x, and those cancel. Hey, what do you know? Yes, it did. It satisfied both tests. So yes, they are inverses. So yes, they're inverses. So let's just go ahead and graph them now. F of x is 2x minus 1. F of x is 2x minus 1. So we have a mx plus b. Our y-intercept's -1, and our slope is 2. Up 2, right 1. Up 2, right 1. Up 2, right 1, and so on. You could go down 2, left 1 as well. All right, but okay, here's our f line, and the g of x, I'll do that in red, is 1/2 x plus 1/2. So it has a y-intercept of 1/2, and from there I'm up 1, right 2. Up 1, right 2, and so on. Or you could go down 1, left 2. And here's our inverse. Here's G. F was in blue. And if you notice, these are reflections about that line, y equals x in black. Right, they're reflections about that black line because they're inverses. A little notation, a side note, right? This does not mean f to the -1. That means f inverse, right? That's f inverse. It's the inverse of f, right? So if I know f is this, its inverse would flip-flop and look like that, right? That would be f inverse. Its inverse. Oops. That would be my f, right? F and f inverse. So instead of g, we'll use f inverse now. So let's go ahead and verify if these two are inverses or not. Well, if they are inverses, then f of f inverse of x would be x, and f inverse of f of x would also be x. So let's go ahead and test this and verify if they are or are not. Okay. So f inverse, f inverse. Well, f inverse is x squared plus 3. And so I'm using f, which is the square root of x minus 3, and I'm plugging that f inverse in. X squared plus 3. So if x squared plus 3 minus 3, that's just the square root of x squared, which is x. So far, so good. Now let's go f inverse. So f inverse, and let's put f of x in red. F of x is the square root of x minus 3. And we're trying to make sure that's x. So again, I'm just working with the left-hand side. F inverse. Well, f inverse is x squared plus 3. And we're throwing that square root of x minus 3 in. Well, square root of x minus 3 times square root of x minus 3 is just x minus 3. So hey, what do you know? So we have verified. So yes, they are inverses, right? They're not, like if I would have ended up with something like, I don't know, 2x equals x, and I'd say, oh, that's not true. And I would have said they're not, right? If it fails, it will not be x equaling x. It'll be something else. Well, how do you find an inverse algebraically? Well, these are our steps. We'll replace f of x with y. We'll flip-flop x and y because they flip-flop for the inverse. Then we'll solve for the new y. So let's go ahead and do that here. Here's f of x. F of x is 2x minus 5, right? So in other words, we have this function with a y-intercept of negative 5 up to right 1. Up to right 1, and so on. Here's our f function. We're trying to find its inverse. So step 1, let's replace f of x with y. Y equals 2x minus 5. So number 1, replace f of x with y. And number 2, we're going to switch x and y. Okay, so the x goes here, y goes there. Everything else stays the same. Because remember, with inverses, they flip-flop. The x's and the y's flip-flop. Now let's solve. Solve for the new y. Okay, so let's add 5, add 5. So I've got 2y, x plus 5 equals 2y. Let me put the 2y over here. And let's divide everything by 2. Divide by 2, divide by 2, divide by 2. So y is 1/2 x plus 5/2, right? Now, the last thing I do is I name the new y f inverse of x, because that's what it is. It's the inverse of f. 1/2 x plus 5/2, okay? And let's go ahead and, you know what, let's graph it. So it has a y-intercept of 5/2, so 2.5. And I'm up 1, right 2. Up 1, right 2. Up 1, right 2, and so on. And you can see that they are reflections about the line y equals x. So that's our inverse. 1/2 x plus 5/2. You can also write that as x plus 5 all over 2 as well as your inverse, right? Now it does say go ahead and verify that these are inverses. So f of x is 2x minus 5. F inverse is 1/2 x plus 5/2. Let's go ahead and verify. So f of f inverse would have to equal x, and f inverse of f would have to equal x. Both of those have to be true if they're truly inverses. So let's go ahead and work with this left one. F of f inverse. Well, f inverse is 1/2 x plus 5/2. I'm trying to make sure that this is equal to x. So 1/2 x plus 5/2 is going into f. F is 2x minus 5. And let's plug that inverse in. 1/2 x plus 5/2. Let's go ahead and distribute that. You get x plus 5 minus 5. X equals x. So far, so good. First half of this is verified. Now let's do this one over here. we have f inverse of f of x, and our f of x is 2x minus 5. So f inverse is 1/2 x plus 5/2, and the x is 2x minus 5. That's it. F is going into f inverse. Distribute that. And sure enough, it does verify. So yes, they are inverses. And we knew that to be true anyways, but we checked our work, right? Let's do this similar approach here. We're going to go ahead, find the inverse, and then we'll verify that it truly is the inverse. So here's our function. F of x is the square root of x plus 7. F of x is a nickname for y. So number one, replace f of x with y. Number two, you got to go ahead and flip those x's and y's. And now we got to solve for the new y. Well, how do we solve for the new y? Well, we got to undo this radical. So we're going to have to square both sides here. So we got x squared equals just a y plus 7. Let me write it as y plus 7 equals x squared. And then I'm going to subtract 7 on both sides. So I have x squared minus 7. Well, that's our inverse. F inverse is x squared minus 7. So now what we got to do is we got to verify. Let's go ahead and verify. Well, if this is true, then f inverse would be x, and f inverse of f of x must also equal x. That's how we verify. So let's start with f inverse. Well, f inverse is that x squared minus 7, and that goes into f. Remember, f is square root of x plus 7. That's what f is. The f inverse is going in. Well, x squared minus 7 plus 7 is just x squared. So we have square root of x squared. And that one works. So far, so good. Now let's do f inverse of f of x. F of x is square root of x plus 7. Well, f inverse is x squared minus 7. But what's going in? F of x. Well, square root of x plus 7 times the square root of x plus 7 is just x plus 7, right? Those are gone, so we just got x equals x, and sure enough, we verified it. And so the inverse of f of x is x squared minus 7, and we have verified that. Here's a little picture of that. The square root of x plus, this is the f function, and then x squared minus 7 is right down here. Now I want to talk about the domain on this. If you look at this square root of x plus 7, right? Notice right here, at this step, we had to square both sides. So you got to be a little careful here when you're squaring both sides to undo that as far as your domain is concerned. Square root of x plus 7 is the square root function, but it's moved left 7. Right, so here it is. So its domain is from -7 on. But if you notice, its range is from y being 0 up, right? Its range is from 0 up. Well, those will flip-flop on, if you were to graph x squared minus 7, it's like this. That's what x squared minus 7 is, right? But the problem is the domain and the range have to flip-flop. So the domain would be 0 to infinity, and the range would be -7 and up. So since the domain is from 0 to infinity, what it does is it cuts off this left-hand side. And it's only the right-hand side of this. Okay. So when you note this, that my inverse is x squared minus 7, you should note that that has a restricted domain. X has got to be greater than or equal to 0 on that, right? Okay. Another way you want to think about that too, x squared minus 7, here's my x squared minus 7. Well, it doesn't, it's a function, but it doesn't pass the horizontal line test, right? So it can't have an inverse. That's why it's a restricted part of that. It's only the right-hand side of that, right? All right, let's move on here. How about this one? We got function f of x equals 2x minus 3 over x plus 4. We'll go ahead and find its inverse. So f of x is y. X and y will flip-flop. So this becomes x. That becomes a y. That becomes a y. Let's write the rest of it. 2y minus 3 over y plus 4. Now we got to solve for that new y. So I'm going to get the y on top. I'm going to multiply both sides by y plus 4. So I multiplied this side by y plus 4 and that side by y plus 4, right? So we have xy plus 4x equals 2y minus 3. Now I'm going to get all my y's on one side, and I'm going to get my x's on the other side. So let me subtract the 4x and take it to the other side. So what I have here is xy minus 2y. That's supposed to be a y right there. Sorry about that. That's a y. Xy minus 2y equals negative 4x minus 3. And the reason I got all my y's on one side is so I could factor it out. I factored y out. So I have x minus 2 left. And then I can divide out that x minus 2. So I have y equals negative 4x minus 3 over x minus 2. Well, that's my inverse of f. And we don't need to verify that. All right. Let's keep going with this one. One more. I have f of x, which is y. Let's go ahead and call it y right now. Y. Let's go ahead and flip-flop the x's and the y's. Let's multiply both sides by 2y minus 3. Distribute that. Let's get all the y's on one side. So I'm going to subtract 3y from both sides, and I'm going to add 3x to both sides. So I have 2xy minus 3y, I don't know why I keep doing that, equals, and I add 3x to both sides, 3x minus 5. Right? I subtracted 3y, I added 3x, I added 3x. Okay? Now we're going to factor out a y. And finally, we're going to divide both sides by 2x minus 3. So we have y is 3x minus 5 over 2x minus 3. That's our inverse. I hope that helps you get started. Thanks for watching. See you next time.